All right, we're looking for David Hansel. So we'll get started now. Thank you all for coming back, and thank you, IATA, for the coffee break. That was much appreciated. So the last session was an excellent opportunity for all to understand what competency-based training and assessment is, and why we need it for remote pilots. Now our second session of the morning will discuss how this competency-based approach looks from the industry perspective, and we'll have some of the same participants, including Farid Zizi. Thank you.
Thank you, Leslie. Thank you, IATA, for the coffee. Now they will be alive. Huh? We have learned in the first session what CBT was. I hope you understood, but I assume that the not so many questions did mean that you did understand. Now we will confront that to training practices to well-known RPAS operators. I don't want to enter in the discussion of RPAS versus small UAS, but obviously there is more to be said on a competency-based framework and a regulatory framework and licensing towards RPAS than to small UAS, which doesn't mean that the same questions shall not appear, because the situation awareness, the unusual situations, the procedures, prepare your mission, etc., and all those questions exist in a different way, but they exist also with small UAS. Let me introduce our first speaker. We will have a sort of sequence which is a bit different to the usual panels. We will have first the operational know-how and experience coming to the floor, and then you see already Nicole and Ashley on both sides of them to frame. So Nicole then and Ashley will then challenge them towards competency-based training on how to evolve or transform, or is it competency-based training what you do? And then we will open for a Q&A. The idea is to go to the question, what does it mean for an operator to move forwards towards competency-based? So our first presenter in this session is David Hansel. He is the Global Aviation Policy Lead for Facebook and their High Altitude Long Endurance US program, AQILA. David is working to harmonize the operations, and I lost my tablet in the same time. And David, as well as I remember what was written, is part of the FAA advisory committee that was mentioned yesterday in the FAA keynote presentation. So David, the floor is yours.
Oh, stop it. Thank you very much. I could not be happier that my bio fell apart on your screen. I hate when people read my bio. It's the most embarrassing thing on the planet. So thank you very much for the opportunity to speak with you all today. I'm honored to be considered among other folks, like particularly General Atomics, to say we're well-known RPAS operators. That is a very high bar to reach, and so I'm honored to be part of this panel. What I want to talk to you about first is what brought AQILA to this conversation. How did Facebook get involved in aviation, and then how are we we looking at our approaches to training our operators moving forward. So everybody here, ideally, I hope, or we've not done our job, is familiar with Facebook. I don't think that's working.
Yeah, this one, to progress. Yeah.
That's what I've been hitting?
Yeah.
Yeah, no, nothing.
Oh.
Oh, everything died.
Then there is an on.
Oh, that's operator error. Good for me. Okay, so everyone knows about Facebook, hopefully. We give power to the people to build community and bring the world closer together. And a number of years ago, we started an effort to connect the other 2/3 of the world that currently are not connected. When you look at the world, it is pretty divided in 1/3 and 2/3 of connected and unconnected. And of those who aren't connected, about 95% of them live in developing countries. What is most disconcerting, if you look back in 2010, we had internet adoption rates year over year of about 14%. Those have dropped to 2014, and they've skirted down a little bit in 16 to about 6 and 7%, which tells us that the bulk of people that we initially got connected to the internet were the easy people, and now it's a technical challenge to get the remaining people on board. 2/3 of the world live in 3G coverage or less, so they're not experiencing the full robust experience that we all get when we connect to the internet. And so what we are trying to do at Facebook is fill the gaps with a number of backhaul capacity options, whether that's in dense urban environments where terrestrial solutions are great, way out in places where population densities are typically less than 100 people per square kilometer, where satellites are incredibly effective. But what I am focused on is that middle population density. 85% of the people who still need to get connected or get better connectivity are in that section in the middle. So what we came up with was basically an answer to a physics problem. How do we get more data quicker to more people? And we thought an aircraft is the way to do it. It is closer to the Earth, so latency is much lower. The bandwidths can be higher based on the medium on which you send the data. And so we started building Aquila. About the wingspan of a Boeing 737, Airbus 320, it's a carbon fiber airframe, so all of the weight of the 1,000 pounds of this aircraft are held throughout the frame. Very simple. It's batteries, it's solar power, and its engines. No landing gear, payload, very, very simple and straightforward. And our mission profile is kind of divided, and this is where we start exploring the competencies that are important to our pilots and operators. Our mission profile varies in 2 very distinct phases. There's the launch and recovery phase, where we are operating from the surface up to, say, 60,000 feet, and that takes us a bit of time to get up that high. As you can imagine, going 40 knots, it's a long journey. But in these launch and recovery phases, we very much appreciate and want to emulate the skills and competencies that you see in commercially rated pilots. We think that the solution and the challenge is actually driven by the environment in which the operators are going to be existing. So they're going to be around airports. They're going to be launching and recovering through airspace which is frequented by Airbuses, by Boeings, by Cessnas, by everything in the middle that you would want to have the competencies of a standard, I'll say standard pilot as just a common phrase. And then the recovery phase is the same thing. It's just in the reverse on the way down, if you could hit that. Where the aircraft, again, in the airport area, it's in the class Delta, it's in a NOTAMed airspace where there may or may not be other traffic transiting. But the unique challenge for our aircraft with what you don't see in a lot of other operations is when we are on constellation. On constellation is from flight level 600 on up to flight level 900. There's not a lot up there, thankfully. And the competencies that we are concerned about might be more similar to what you have as an air traffic controller. Probably a more interesting parallel for those of us in the room, I'm a former controller myself, for those of us who are controllers, the RO drivers, the folks in the back who are driving the planes for the student air traffic controllers, as they acquire their skills, that may be a better parallel for us in terms of identifying competencies. The mission profile has us climbing throughout the day and descending throughout the night, and quite frankly, is it more important in those circumstances for me as an operator to have a competency that revolves around high altitude weather and the unique nature of that and traffic management, or am I more concerned about the skills that a pilot may use to see and avoid when operating in VFR airspace? So this is where we see a very clear delineation between kind of our two crews, for lack of a better term. The mission profile is basically a 90-day profile. So we get into the challenges of long endurance, not just for the aircraft, but for the operators. If we have a constellation of aircraft, meaning up to 100 aircraft flying in AOR, how do we divide those responsibilities among a minimal number of pilots and operators to keep this cost effective while maintaining the same level of safety that we have come to love and expect in the commercial airspace that we enjoy today? And it's a very early challenge for us. There are folks who've been doing missions in these airspaces and in unmanned paradigms for a very long time, but we're brand new to this. And so we view this very much as an exploration and a partnership with civil aviation authorities, air navigation service providers, and other operators to find the best practices and identify the competencies that these operators will need. I think an interesting parallel is if you asked Henry Ford in the late 1800s and early 1900s, hey, what does it take to be a good Formula One driver? How can he even answer that question? How can that question be answered? And the simple solution is, the simple answer is, I don't know. And be honest about that, and let's find out what those are, and let's find out about those together. This is an exciting opportunity. It's a way forward that, while it has basically never been seen before, the foundational issues that we face are known to all of us. And what competency-based training really provides us is a foundation of educational training and knowledge on which we can build. So I look forward to the conversation. Any questions you might have, we'll look forward to answering them on the panel. Again, thank you for the opportunity.
Thank you, David. So already a few questions, and be sure that the two madams will ask a number of questions to you. Ed, as I understood from your bio, you were very well involved with warfare and the involvement of remote pilot aircrafts in it, and a key member of the team which developed the MQ-1 and MQ-9. I don't know what it is, but MQ-1 and MQ-9, but also flew a number of operational missions for US and international customers, as well as being an examiner. And now what is very appealing is that you are much involved with advanced technology and the engineering team on future user experience designs. So this is not exactly the purpose of your talk, but at some point at the break it might be interesting to explore that concept. Ed, the floor is yours.
Thank you. It is a privilege to be invited to speak here. So I greatly appreciate it. I got the call that said, hey, would you like to come to ICAO and speak about competency-based training? I said, of course, I'd love to. I just have one question. What is competency-based training? So after Ashley explained it to me, I said, well, that's pretty much what we've done for the past 25 years at General Atomics. So in a sense, we've been doing competency-based training for 25 years. We just didn't know that that's what it was called. So we have been flying the airplanes. Brandon gave a presentation yesterday, so I assume you're somewhat familiar with our aircraft. They're large aircraft that we fly in the flight levels. We've been integrated with manned aircraft for over 20 years now, both in the U.S. and overseas at various operational deployments. Here's a quick makeup of what our crew normally looks like. We have a pilot that's the pilot in command. He flies the aircraft. He's a licensed pilot, and we'll get into that a little bit later. We have a sensor operator who their primary function is to operate the sensor, but they also serve as a co-pilot. We run checklist, challenge response style. The sensor operator usually takes what we would call, in the airlines, would be pilot not flying. They pick up some of those responsibilities, such as communications and those things. We have a crew chief out at the aircraft when we launched the aircraft who helped us with the pre-flight. Once the airplane's airborne, they're not normally part of our crew, but they're always available. If there is an issue, hey, the engine oil pressure is not looking right, we can always bring those guys into our ground control station, and they can help us assess what's going on with the aircraft. We have our avionics technician that is involved with the electronics side of it, and they sometimes serve as a flight engineer for us. When we hire pilots, our current requirements are an FAA commercial certificate with a current instrument rating, 300 hours pilot and command time, and for pilots who become advanced instructor pilots, it's required that they have a CFI. Within our pilot group, we have when you're first hired, you're a student pilot until you're qualified. Once you're qualified, you're a mission pilot. Once you get that initial qualification, we have a number of contracts with various customers where we go out and supply them with pilots to fly their operational missions for them. So as soon as a pilot is qualified, they get into rotation of 3 months out, 3 months home, 3 months out, 3 months home. So there's that continuous rotation of operational flying and back to home base. Once a pilot has deployed a couple of times and has the qualifications, we'll upgrade that pilot to an instructor pilot. So when they come on their home cycle, now they are instructing other pilots. We have an evaluator pilot, so our senior instructors then become designated as evaluators, and they give the final check rides for qualification. And then finally, we have test pilots. Our test pilots typically have about 10 years experience in the aircraft, and they do flight tests. But again, they stay in the rotation, so they go out and deploy. So it's a constant cycle of at home either test flying, or if they're not scheduled for a test flight that day, they're brought in and they instruct as well because they're instructors. So the test pilots can give it just an extra level of system knowledge to the student pilots, and again they also go out and deploy. So they always bring back the current situations or current experiences of what we're seeing in the real world. So as we get into competency-based training, the first question I always get is, oh, you fly UAVs, you must be really good at video games. It is not a video game. I'm not good at video games. I'm pretty good at solitaire. But you never forget that there's 10,000 pounds and $10 million worth of airplane out there that you're responsible for. So in that respect, it's nothing like a video game. The other point is not everyone gets a trophy. There's a certain number of manned pilots that just can't seem to make the transition to flying UAV pods. So there is some attrition in our training, and there's no really, you can't look at a pilot's resume and tell who's going to make it and who's not. But pretty early on in the training, it becomes apparent as who's able to make that transition, who's mental. And I guess the key factor we've talked about earlier was the key to being successful as a UAV pilot, from our perspective, is the ability to kind of put yourself in the airplane. If you ask me, where are you right now? Well, if you came to me while I was flying and said, where are you right now? I'd tell you I'm 12 miles north of the airport at 8,000 feet. Actually, I'm not. I'm sitting in a trailer on the ground, but mentally, that's where I am. And so for us, the approach that we've always taken is we're just transitioning a pilot to another type of aircraft that he's not flown before. So it's like a type rating in that sense. The one big additional feature is the data link. So now while flying the airplane, you also have to manage that data link. So this is kind of a typical syllabus would look like. We would start out with a classroom ground school, pretty typical. We would do something on the order of 10 hours of simulator training, and then we'd move into the aircraft and probably do about 40 hours. These numbers vary, but this is just kind of a template. In addition to the hour requirements, we also track event requirements. As you can imagine, an airplane that flies 40 hours, you can get a lot of training in it, but you only did one pre-flight sequence in that 40 hours. So we do have to track and make sure that each student gets their fair share of each event. You know, we do a lot of touch and goes, obviously, to save time, but touch and go is different from a full stop landing where you're using reverse thrust, for example. So we do track those kinds of details as well, just to make sure that the student is getting exposure to everything. And so I kind of broke it down. These are kind of the core principles, I think, when you look at our training, is aircraft control. Can the pilot put the aircraft where he wants to consistently every time? Systems knowledge, this is a big one. Does the pilot understand all the systems on the aircraft? Does the pilot understand all the systems on the ground station? Does the pilot understand the data link? And does the pilot understand how all that works together? That's the key for us. A lot of the aircraft that we deploy are, technology is rapidly advancing, and they've gone through flight tests, but they're not necessarily mature technology. Our customer wants every new feature yesterday, and so we've got relatively immature technology at times that goes out in the field. So it's that system knowledge that we expect the pilots to fall back on when they're out there. Crew resource management is another big piece for us, and that involves communication as well. RPA flying for us is a team sport, and the PIC is kind of the quarterback of the team, but it takes all the team members doing their job, and it's that pilot making sure that he utilizes all those resources effectively. Safety and judgment, I kind of put those in the same category. Good judgment is usually safe decisions. Bad decisions usually are unsafe. So competency-based training, kind of how it works for us is, as I said, we feel like a solid foundation in systems, understanding the systems. It gives the pilot the ability to think independently while operating the aircraft, and that's one of the things that we as we're training, we go through. We're always going through simulated emergencies. If this failed, what would you do? So the instructor is constantly asking the student and trying to get that feedback, looking at the student's thought process, making sure that the student understands what's going on, is able to assimilate the information, and knows what to do. Why are you doing this checklist step? So we have, like any other aircraft, we have normal procedures, we have our emergency procedures. The pilots are stepping through the checklist. But we always ask them, why are you doing that step? This says put the switch to auto. What happens when you put that switch to auto? What system is that controlling? What sensors are feeding back into that? We want to make sure that they understand, what's going on. Why would you ever go back to manual? What would cause you to put that switch in manual? Whether it's normal procedures or emergency procedures, we want to make sure they understand why they're doing those things, because they may encounter a situation where there's an exception where maybe you don't want to do that checklist step that's prescribed. And then we're always just throwing out the what ifs. What if this happened? What if that happened? And again, it goes back to getting a feel for what that student is thinking, and if they're assimilating the information they need and making good decisions with it. So as I mentioned earlier, our instructor pilots are constantly deploying. So they've recently, anytime a student's flying with an instructor, that instructor has come back recently from an overseas deployment. Like I said, our test pilots are also instructors, and so they'll rotate through. So a student may get a chance to fly with a highly experienced test pilot who's flying the next technology, and can kind of give that information. Hey, you're not going to see this feature yet, but in a few months you're going to see this thing that I'm testing right now. And our instructors, regardless of the level, are constantly coming back with their "there I was" stories. And that's to me, competency-based training is what we're really trying to do is we're trying to transfer our competency to the student. And so one of the ways we do that is just giving them examples. Hey, here's a situation I was encountered. I had trained for this, but then this happened. This is the decision I made. This is how I handled that situation. Those kinds of things. Hangar flying. When the students are sitting around, with one airplane and 5 students, there's a lot of time spent waiting your turn. So when those students are sitting there waiting their turn, they're sitting around challenging each other, talking about the things that they've learned, challenging each other, going through various procedures, situations, whatever they might encounter. And as we're progressing through the syllabus, there are phase checks where the instructors will evaluate them, make sure that they're making the progress that they need, and ultimately there'll be a check ride with an evaluator at the end, and that evaluator will certify them for operational flying. Previously, most of our flight training has been either internal, training our own company pilots, or coupled with an aircraft purchase. A new customer will come in, they will buy X number of aircraft, we'll train their initial cadre of pilots. So typically that's been the model we've used in the past. Recently we've opened up in Grand Forks, North Dakota, a new training academy to try and capture some of that third-party market. It's a rural area, so it's uncongested and it's UAS friendly, as there's a lot of UAS operations up there already. It's OEM instructor pilots. I kind of harp on this a lot, and I'm probably biased, but I really think that since we work for the manufacturer, we have a level of understanding of the aircraft that just no other third party is going to have. And there's pride of ownership. I mean, we really love our airplanes. We're proud of our airplanes, and we love teaching new students how to fly our airplanes. We have a partnership with University of North Dakota, who's doing some research with, done a lot of research now with UAVs, and so we're partnering with them. We have our PMATS, which is a new simulator that really captures the full capabilities of the aircraft. Previous versions of our simulator were better than part task trainers, but they weren't full-on simulators. This one's a full simulator, so that really helps us cut down the training time. And so we're looking for international partners, Air National Guard, third-party contractor aircrew, and then of course we still maintain our own internal training. So I guess in summary, someone made the point yesterday that remotely piloted aircraft are aircraft. We would agree with that, and based on that, we train like we're training people to fly an aircraft. Competency-based training, although we didn't know what it was called, we've been doing it for 25 years, and we've been really successful at it. And so I would encourage you to, take whatever you can from our experience. We'd be glad to share with you. I guess we won't be taking questions now. I'm sorry, this is an old habit. There's always the question slide. But there's my contact information if you email, if you want to jot that down, and I'd be glad to talk to you guys at the break. Thanks.
Thank you, Ed. As you already captured, remote piloting is not playing video games. But there is this question of virtuality versus reality when in the situation awareness paradigm, which is dealing with remote piloting. The other word that you pronounced at least 10 times is understand. And so let's go now to Stuart McGlynn. I'm not too sure with my accent. It's not a Scottish one. So with 17 years of ATC background as an officer of the Royal Air Force, he was also a qualified instructor and examiner and completed deployments to Iraq and Afghanistan in a very operational environment, I imagine. And after that part of his career, he became consultant with aviation industry, helping the UK CAA, as well as the Dubai Air Navigation Services for business plan and strategy. And he recently joined the RPAS industry, and he is now aviation advisor to Cyberhawk. And what's interesting is in the panel is we have former controllers and former pilot, and it's really interesting when we discuss competency. So the floor is yours, Stuart.
So, ladies and gentlemen, very good morning to you all. And Leslie, a big thank you for the opportunity to speak today. It really is appreciated. As most of you are probably not as familiar with a company called Cyberhawk as you are with some of the other speakers today, I will provide a short overview about who we are, what we do, and the type of aircraft that we fly. But then I'll concentrate on providing an insight into our training pipeline, how we use a competency-based approach to train our pilots. Then I'll conclude with looking at a couple of the challenges that we face with some of those competencies, and then what's next in our industry with regards to competency-based training. So as a company, Cyberhawk provides aerial survey and inspection services using small, let's say, RPAS or small UAS, sub 7 kilogram category. The company was founded in 2008 and has around 50 employees. Head office is in Edinburgh, and we have other offices in the US, Middle East, and Malaysia. We have operated in over 25 different countries and completed over 21,000 flights. And then separate from the operational side of the business, we're also a national qualified entity. And what that means is we're approved by the UK CAA to deliver training and assessment of RPAS pilots. Our key industries are predominantly oil and gas, both on and offshore, and that includes shipping. Renewable energy, such as wind turbines, utilities, such as electricity pylons, rail infrastructure, and land survey. Our clients include many multinational companies, such as BP, Shell, ExxonMobil, Petronas, and Siemens, to name but a few. Our primary aircraft is very different in size to the previous speakers. We use an Intel Falcon 8, a small 2.2 kilogram octocopter that can be fitted with a range of payloads. And this is our aircraft of choice for inspection tasks, although we do use it for some survey work as well. We make use of the flyability Helios for internal inspections or inspections in confined spaces. A Mavinci Sirius Pro that we use for larger survey tasks. And then the Inspire 2 and Mavic Pro for dedicated video work. Our pilots are drawn from a cross-section of experience, some of those from manned aviation, both rotary and fixed wing. We have quite a few from the oil and gas industry for obvious reasons. We have qualified engineers and inspectors that we multi-skill, some from rope access backgrounds from a similar sort of industry, and also quite a few ex-military like myself. The common thread across all of those tends to be that we come from a background of managing risk, and I'll explain why that's quite important in the competencies in a few moments' time. The flying experience ranges from over 500 hours on our primary aircraft to one that's just completing their first commercial task today. So the left-hand side of this slide shows the Cyberhawk training progression through to obtaining a pilot certificate of competence that allows them to operate commercially. For our basic pilot training, we use a competency-based approach that provides a structured progression through the training syllabus, and it enables that syllabus to be tailored to the individual pilot skills and experience. If a pilot can demonstrate the required level of skill and competence, then they are able to move on to the next stage. Training commences with the mandated CAA theory course and exam, and the modules for that are listed on the slide. On successful completion of that exam, pilots then commence their internal competency-based training with us. So initially the pilots concentrate on their manual flying skills, and for this we just use a very small rotary-based trainer about the size of your hand. The flying takes place indoors in a nice, easy environment where pilots can practice their skills in the hover and also in figure-of-8 type maneuvers. But also at this very early stage, we introduce the use of checklists for both pre- and post-flight checks, gets the pilots into a good habit, but it also has the added benefit that they get used to communicating with the other members of the team as they communicate those checks as part of the training. As the basic level of competency improves, then pilots progress onto our Cyberhawk rotary trainer. Now, this is a custom-built, scaled-down version of our primary inspection aircraft. Only it's a bit more challenging to fly. So during this phase, pilots continue to develop their manual skills, but we introduce some extra competencies, such as flying the type of profile that they will do to inspect structures. And by the end of this phase, pilots should be highly competent with their manual flying skills. The use of checklists will be a matter of routine, and they'll be used to communicating with the rest of the team throughout the flight. The conversion training sees the pilots transition onto our primary aircraft, the Falcon 8. And by this stage, the actual flying element is much easier as we introduce GPS and flight-assisted modes. And what that allows us to do is to introduce two very important competencies, that of the flight planning process and also conducting risk assessments. We see these as key competencies that underpin the safety of our operation. By now, pilots are able to operate the aircraft in manual and assisted modes and complete all pre- and post-flight actions. The competencies introduced in the basic survey module, as highlighted there, are now less about how they fly the aircraft and more about how they capture and handle that data. So this includes knowledge of photography techniques and the selection of the right payloads for the task that they're going to do. Basic training concludes with the pilots completing the mandated CAA practical assessment that assesses a range of specific competencies. And successful completion of that enables a pilot to fly commercially in the UK. Quite a busy slide next, but I'll step you through it. Because for our pilots, the CAA check is actually just the beginning of their training. By this stage, they have the core competencies required for the level of work that they're undertaking. They're adept at flying the aircraft, at flight planning, risk assessments. They know the emergency procedures. They're practiced at leading teams and problem solving in a low-risk environment. So they're now given a period of on-the-job experience to really hone those skills before progressing onto more advanced training. We have a dedicated survey department, and so some pilots will complete the survey advanced module on the left-hand side of the slide there. And this introduces our fixed-wing aircraft and operating on extended visual line of sight. More commonly, others will follow the progression through utility basic, which is wind turbines and electricity towers, through to utility advanced, which provides an offshore element to those types of structures. And then pilots will eventually progress on to industrial training in oil and gas facilities. However, for those with the right experience and competence, such as previous flying or knowledge of the oil and gas industry, it is possible for someone to progress direct to the industrial basic module. Now, a few years ago, the training pipeline would have been through utility first and then on to industrial, and that was regardless of pilot competency. So this has helped to streamline our training. In addition to the structured progression through advanced training, pilots also complete some standalone modules. This is for areas like congested or operating in congested areas, or operating for internal inspections, some of which require particularly unique competencies. The lack of a common license also means we're required to do training and assessment for other aviation authorities. Most common is the Part 107 exam for the FAA, but also training and assessment for the Irish Aviation Authority and for ENAC in Italy. For operating in over 25 different countries, we're used to the time and cost of completing similar assessments time and again. On this slide, I've put a selection of the ICAO competencies that are highlighted in bold. We find the competencies are sufficiently generic that they can be tailored to allow the required observable behavior that can then adjust for the type of aircraft and the environment which they're going to be used in. So below each of those competencies, I've listed a few examples of the observable behavior that we would look for as part of our industrial advanced training. So having given you a snapshot of our competency-based approach, I'll just touch on a couple of the challenges that we face. Firstly is the ability of our pilots to operate across a diverse range of environments all over the world. This gives rise to a spectrum of hazards that need to be identified and as much as possible mitigated during the flight planning and risk assessment process. So factor in that many of those pilots are from non-aviation backgrounds, and the challenge becomes even greater. So we need to be able to equip our pilots with the competence required to assess any environment, to consider the hazards, and to understand the severity. They need to be adaptable, resourceful, even inquisitive. These are not easy competencies to teach. When inspecting offshore platforms, the pilot needs to consider a diverse range of hazards in addition to coordinating the activity of manned helicopter flights. This slide just lists a few of the hazards present when operating offshore. For someone unfamiliar with a production platform, a lot of these hazards will not be readily apparent. A platform can be noisy, busy, full of distractions, But we need our pilots to remain focused, but still have an eye on the environment around them. So whilst hazard identification is a difficult one for us to teach, particularly those new to aviation, the difficulty with a competence in manual flying skills is actually more one of retention. The use of GPS and automated flight control systems aids control and makes the aircraft easier to fly. However, the use of the automated systems for the majority of the tasks that we do can also lead to a dilution of the manual flying skills. Why does this matter? The GPS signal is not always 100% reliable in some of the areas that we operate, particularly in congested and industrial areas or under structures. And manual recovery may be the only option. So we ask, can the pilot recover the aircraft if GPS signal is lost unexpectedly? What do we want them to be able to do? Also, we've got an increasing number of tasks where manual flying is actually required. So for example, the inspection underneath an oil and gas platform. This could be particularly challenging as the pilot might be controlling the aircraft under a slightly different perspective, where they're actually looking down on the aircraft rather than looking up. Particularly turbulent air underneath the platform can be a challenge. And then they need to recover that aircraft back to a very constrained area, potentially even into somebody's hand. Manual flying is also required for a number of indoor inspections, such as storage tanks inside a ship or inside chimneys or ducting. So as mentioned earlier, our pilots are well trained in manual flying techniques. The challenge for us is to enable that competency to be maintained. So currency is very important, and we check the manual flying skills on a regular basis. So in summary, competency-based training is already very much in use at Cyberhawk. A competency-based approach focusing on skill sets forms a backbone of our basic training and goes beyond what is required by the UK CAA to obtain a certificate of competence. Our postgraduate training also lends itself to a competency-based approach, as training-specific skills are required for different industries, and a competency-based approach allows us to tailor that training depending on the pilot's skills and experience. One of the greatest challenges is developing that awareness and knowledge to identify the hazards and skill to adapt to a variety of the environments in which we operate. And what happens next? Well, several industries such as oil, gas, construction and rail now appreciate the difference between those who have attained the minimum national certification standards and those with a greater level of competency. So industry bodies are now in the early stages of developing specific pilot competencies appropriate to their industry. To a large extent, we've done this already internally as a company, but industry is now looking to develop a set of common training competencies. And it will be interesting to see how those competencies are reflected in those that are set out for the remote pilot license. Ladies and gentlemen, thank you very much for your attention.
Thank you, Stuart. Perhaps two words after this presentation. One, perhaps that we didn't underline sufficiently in the first session, is the benefit of the competency-based framework to adapt to the trainee and the existing experience of the trainee, and you demonstrated it very well, this capacity to tailor. The other thing which is also interesting from your presentation is this notion of core competencies, which could be common to everybody, and then additional or specific ones to the dedicated job that you do, the mission. Now we will play a specific game. You have heard the experience of our three operators here, or the projects, because some Some are launching new projects. It's especially your case, Facebook. And what I would like is Ashley and Nicole, as CBT experts, let's call it, to challenge a bit and enter in this discussion. Okay, are you really competency-based training or not? Or what do you need to transform, or what do you think you need to transform, etc.? Ashley, the floor is yours. I saw you taking the mic. Here is it.
Thanks, Farid. You know, before this session started, in fact, sometime as a general comment, of course we had some insight as to what people were going to present. We knew what was going to be said. And so I had this wonderful thing that I was going to say, which I've just decided to scrap completely and say something else. Because one of the things that's coming out of this morning's session, and having listened to the operators talking, is there's a common thread that's coming out here. As you've just mentioned, Farid, we talk about it seems like there are these common competencies. When I look at your completely different operations, they're radically different to each other. And yet, one of the messages that comes out is there are a certain set of competencies that, irrespective of the tasks that you're involved with, irrespective of the type of operation that you are performing, you still need these competencies, right? The second message that comes out is that even though there are these common competencies, there's also this possibility and likelihood that there are some unique competencies that might apply to a particular operation. And then there's that third message that's coming out, which is, well, actually for our operation, we have a good idea, but actually we're not sure of all the competencies, and maybe with time and with experience, we will figure out that there are some competencies that we are currently not aware of. So I think that it's worth repeating that the ICAO competency framework is very well suited to this particular context that we find ourselves in. And I think that that's a huge advantage to this community, that this flexibility exists. So what I'd like to do is maybe just go back to this statement that is being made over and over again, that there are common competencies, and I'd like to actually explore that a little bit further, because when I translate the common competencies into air traffic control terms, there is another advantage to doing competency-based training and assessment. And that advantage is that those competencies are transferable. And what I mean by that is if you have an air traffic controller, or for that matter a pilot, who has demonstrated competence in one particular unit, and then they move to another unit, of course, they need to learn the new procedures, they need to learn the new airspace. But what they take with them are the other competencies. They still know how to do situational awareness. They still know how to communicate effectively. All of these things go with them. And that's the beauty of competency-based training. And it's not only about beauty, it's also about cost efficiency, because you're not having to retrain any of this, right? Now, when I think about that particular advantage in RPAS, there's a question that I would like to put to you. You've all spoken about these common competencies: situational awareness, problem solving, workload management, that are common. But you have very different operations. And the question that I'd like to put to you, and mainly it's to Ed and Stuart, is do you believe that the competencies between your two different operations, the common ones, the workload management and the communication, are they transferable between your operations? Would you be confident that somebody coming from the Cyberhawk operation has the competencies that you need for your operation, and of course vice versa?
There is a second mic.
I would say no. I mean, the airplanes are very different. When we fly, our airplane has a camera in the nose, and and the pilot's viewing the world through that nose camera. So for me, transitioning from a Cessna 172 to a Predator is pretty simple. It's instead of looking out the window, I'm looking through his nose camera. So it's pretty similar because I'm still in the pilot seat, that pilot perspective. Trying to fly one of these smalls, and I've never flown one of these small UAVs, from the third-party perspective, for me would be very difficult. And I don't know much of what my current skills would transfer over for that. So I think, certainly for me going to that, I think I would have a lot of difficulty.
I'll maybe just put a slightly different perspective on that, in that I quite understand from a perspective of operating an aircraft, and the skills required to fly the aircraft may be very different. But I think some of the skills of airspace awareness, so being able to risk assess what that aircraft is doing through a particular piece of airspace, who does it affect, why does it affect them, what's the consequences of being in that piece of airspace with that aircraft, I think those skills are very transferable. I think things such as use of checklists, verbal communication within the team are all transferable skills. You see a lot of us have come from air traffic or pilot backgrounds, and the reason we're able to bring knowledge to this industry is exactly that. It is transferable skills that we are bringing to the RPAS industry. So when I assist RPAS companies with what they're doing and their aviation perspective, that's because I'm bringing transferable skills to the industry in terms of how we risk assess things and how we manage safety management within that industry.
David, do you want to have a say?
We very much take the approach that that we don't know. We're going to be very frank about that. This is such a nascent, not just the technology, but combining the vehicle with the type of operation in the environment that it's being conducted. That's a really hard future look for us to say and make any sort of valuable judgment out of it. But while we don't know, we are wildly open to understanding it, and I think that's what's important in these spaces, and exploring, is there value in some sort of, if there were transferable competencies, okay, does that have an inherent value in and of itself to civil aviation authorities in terms of licensing or establishing a baseline of hiring? We don't know, but there's a lot of great foundational knowledge out there to explore the question, and that's kind of our perspective on that.
Ashley, Nicole?
So, Dave, actually, I'm going to put you on the spot. Oh, good. I want you to make a stab at figuring out what kind of person you would recruit for a high altitude, long endurance person. So, if I knocked on Facebook door and said, I want to be a pilot for you guys, would it be better for me to be a controller that plays with drones, or would it be better for me if I were a commercial pilot? You kind of touched on it, during your presentation, but if you could expand just a little bit.
Yeah, absolutely. So, as you mentioned, so I started out talking about the differences in our two very distinct phases of flight. And I think being early in the evolution of this program, what we think, the important approach is what we think today makes a good pilot or operator, depending on how you slice the pie there, might not be what we get to in 5 years. We're at a great phase in the cooperative efforts between CAAs and manufacturers and operators that we can explore that together. In the last session, someone asked that question about controllers. We had X number of years to understand this, and we don't have that. We have some great parallels, and I would use the parallels as a starting point. So obviously you look at the environment in which the aircraft are going to operate. Somebody going up and down through commercial airspace, for the purposes of safety, at the onset of this endeavor, I would love to have an ATP CFI, CFI, carrying that aircraft up. But once we get up to 60,000 feet, that environment is entirely different. And now maybe a controller and someone with those competencies, maybe they're the best person for that. What I like about the competency-based approach to training, I'm sure everyone here has memorized the PANS, and when you look at, right at the beginning of section 2, there's that chart that talks about the distinct phases, and engagement of human resources is a big part of that process. So you're constantly analyzing, okay, are these the competencies that we need, and if so, if so or if not, let's engage HR to make sure we're hiring for those skills. So I think we start with a baseline of let's have familiar skills that the world can be comfortable with, from a baseline of safety, and then let's evolve as we go. So 5 years from now, maybe our initial cadre, who were great hires, maybe 10% of them are what we would then identify as the holders of the competencies that we want moving forward. But that has to be evolutionary, it has to be cooperative. That's kind of our initial approach to it.
Just want to add just a little comment to what you just said, but what I find interesting in that, what you just described, is this idea that it's not done for once and then you revisit 10 years down the road. It's continuous. You will continuously look at the competencies so that they keep making sense for your operation.
Right. And I think that you look at the baseline, like, I think it's an excellent example if I'm going to go talk with civil aviation authorities to say, look, General Atomics has been doing it this way with these kind of pilots very safely for decades, right? That's valuable information. What can we glean from that? And Cyberhawk has been doing it in a different paradigm very safely for tens of thousands of flights. Great. What can we take from that and integrate to make the best situation for civil aviation authorities and for the general public?
Thank you.
Ashley?
So Dave, I'm an air traffic controller who flies a Mavic. When I get tired of my current job, can I call you? Actually, Ed, I'd like to come back a little bit to, we're talking about in the Facebook context, which is a very new type of operation, they're still really having to think about who they're going to recruit and what the right profile is and what the right competencies are. But in your case, I mean, you've been doing this for a considerable amount of time, and you know quite clearly what your entry requirements are. And if I remember from your presentation, you were saying, you need somebody who has a CPL with an instrument rating. So clearly you're taking on board already competent classic pilots, if you like, and converting them into an RPAS operation. And the question I'd like to put to you is, do they transfer their competencies, CPL to RPAS, easily? Do they have difficulties in doing that? Do you see any competencies that are emerging that your classic pilot doesn't have?
Yeah, for the most part, they do come across directly. You take the instrument rating, for example. Some places we fly on an instrument flight plan. I mean, you have to have an instrument rating to fly on an instrument flight plan. Our pilots have to maintain, we have a program where they maintain instrument currency in a manned aircraft in parallel to their UAV qualifications. So for the vast majority of the things do transfer over. But like I said, there's just some people that just don't quite seem to make that transition. And there's really, in 25 years, I've never seen a correlation where I could look at a resume and say this guy isn't going to make it. After an hour in the simulator, I can tell this guy isn't going to make it. But as you look at the resume in terms of experience, age, qualifications, whatever, there's no marker. There's certain people just don't make that, that spatial transference or spatial presence that we call it. That's the one that, from what we've seen, that's the one big thing that doesn't. That's the one thing that trips people up. Just certain people it's just this thing that they just don't get.
Sorry, Ed, can you just explain what spatial presence? Yes, can you explain just a little bit what that is?
Sure, that's a term that the psychologists use for players who are playing video games where it's first-person shooter type games where you're immersed in the game and in your mind you are in that world. When I'm flying the UAV, I'm viewing the world from the perspective of the aircraft. So that's what that is.
Last one, Nicole, and then we will offer the floor
Very
for
good.
Q&A.
Stuart, next victim. So you've described very well all the competencies that you use in your Cyberhawk operations, and you've described how all the competencies need to be demonstrated in an integrated way. You need to see all of them working together. And you've touched on this during your presentation, but I'd like for you to expand just a little bit. Are there any competencies that you find are more difficult to teach or to assess? And why are they difficult to teach and or assess?
I guess the distinction I can make is in terms of controlling the aircraft. It's fairly distinct whether someone can control the aircraft in a particular way, in a particular scenario. So that's quite easy to assess whether they have that competency or not. It's some of the more human skills that are the difficult ones to assess. So what we try and do there is build them up over a period of time. So in terms of risk assessment, rather than trying to teach them everything there is to know about risk assessment all at once, the first level of competency might be actually quite basic. And then we will build them up through levels of training so that their risk awareness becomes much better. And then also how we assess that is, whilst we do have levels of practical assessment within the operational process, if someone's completed a risk assessment, another pilot will do the first check. So even before it gets to a sign-off stage. And what that does, it allows us to see, to make sure that they do have the competence, but there is also a transfer of knowledge from one pilot to another because the experiences are very different. So that's partly how we sort of help keep on top of the ones that are a little bit more difficult to either train or assess.
Thank you. So, you passed the exam. No, but I think it's interesting to have this exchange because a number of operators operate in a dedicated environment and they don't look at what they could exchange. And I think I was very interested by the discussion. I could stay a longer time. I'd like to open the floor for questions, and since I'm not very keen to look with those computers, let's show of the end if there are people. Yes, madam, I imagine you are British. You are Australian, but you sit beside our British friend.
Yes, we're good allies.
Okay.
My question is, with the competencies and the core competencies that you have been looking at and starting to develop as part of your training programs, do you have a component of that focuses on non-technical skills and behavioural markers for assessment?
I would first target one of our three gentlemen, and then, Mesdames, you can try to get it. But I'm interested by the operational answer to it, and then we can have the CBT answer to it.
I think in the formal sense, the answer is no. What we do try and do is right from the very first part of recruiting someone into the training stream, then that's one of the backgrounds that we might look for. And then as they progress through the training system, then obviously you get to know that person very well and you understand their behaviours, their aptitude for risk, and particularly with the type of aircraft that we have, it's very easy to operate that aircraft in a non-responsible way. So again, that's the sort of trait that we would look for during that training process. So whilst it's not formally assessed at this stage, it is something that's very much in the minds of the type of person that we want to operate and how we train them through the system. Yeah,
I would say with us, it's not a distinct thing that we check for either. if it's in terms of, you know, does the person operate the aircraft safely in terms of judgment, that kind of thing, then they're going to advance. If it's the question of, do you really want to spend 12 hours in a ground control station with this guy? You know, if he's competent, he's probably going to make it through the training. But you, and to a certain extent, you kind of, you have to just be professional, and you know, maybe I don't really enjoy working with this person, but he's competent, I'm competent, we can work together as a team. You know, we put our differences aside while we're in the GCS flying the aircraft.
Ashley or Nicole? How to approach the question?
It's a very interesting question, and I think it's a question of vocabulary. One of the things we had to resolve when, remember in my presentation in the first session, I described that we ended up with two different concepts of what competencies were. And while we were trying to resolve what the definition of competencies should be, one of the things we looked at were these notions of technical and non-technical skills, competencies, behavioral markers, et cetera, et cetera. One of the notion that we inherited from evidence-based training is that we don't discriminate non-technical from technical competencies. You need both sides to come to work together for a fully competent performance, right? You talk about behavioral markers, we talk about observable behaviors in ICAO competency framework. So I think those notions are embedded in you know, the ICAO provisions. So,
Ashley, a last word?
I think what it comes down to is, you can call it technical competencies or non-technical competencies. I don't think that that's, to make that distinction doesn't help us too much. I think what's important is that you answer the question, what must this person be capable of doing in order to be considered competent? And if the conclusion that you come to is that some of those soft skills are essential to the competence of that person, then it has to be evaluated. Is that easy to do when it comes to some of the softer skills? No. It's one of the most challenging ones to deal with. In the air traffic environment, of course, everybody can follow the procedures, they can separate aircraft, they can do all these wonderful technical things, but very often, everybody knows that the problem might be an inability to integrate into the team, and that has safety implications. But it is much more difficult in an assessment environment if you don't have the behavioral markers to find evidence either that that skill is there or that it's not there. And I think yet again that that's where the framework is helping us, because it gives us those behavioral markers to say you have this competence or you don't have the competence.
Thank you, Ashley. Another question, I will take one or two still. We have 3 minutes. There is one, yes, Mr. in the back. Push on your button beside the, and as soon as it becomes red, you have the floor. I don't decide.
Thank you, sir. I would like to commend Ms. Ashley a while ago. Well, she spoke about the competency training for air traffic controllers, and I do believe that that has got to be the same with the remote pilot license in the future. Likewise, it is also being done for pilots, okay? For remotely piloted aircraft system, we have to lay the foundations of how we will do the trainings, ab initio training, like that. Of course, it is really very important that we are doing all the safety initiatives all over ICAO member states, and to determine how a pilot of a remote piloted vehicle will be able to fly the drone safely wherever they are in commercial operation, which is different from skills, hobby, amateur. These commercial operators, which is now being practiced in the Philippines, we do certify them prior to the commencement of their planned schedule for photography, aerial photography, wedding coverage, news like that. I do believe with the symposium that we had yesterday, today, and the next days to come, we will be, all of us will be able to comprehend what will be the best solutions. Right now, we are really doing everything to do these safety enhancement initiatives, steps, how we do the training. It is really very vital to all member states to determine how this guy will be able to fly. How do you know if this guy can fly this UAV safely, like the observable behavior, like example, mitigating circumstances, identifying risk, okay? So those are really on, based on risk assessment and then the mitigation. So it is really very vital for operators engaged in this kind of business to be able to know everything, including those amateurs. Thank you, Madam and sirs. Thank you.
Thank you. I'm not too sure I did catch the real question, but at least what I understood from what is perhaps more a comment than a question is the challenge of the operator and even the training provider to demonstrate the ability of mitigating the risk and managing properly the safety to the authority. I think we will have that in as part of the next session. But where you are true and totally true, and that's the question of that we had here, is that it's not a question of having a framework only and then providing training, is being sure that what you train is adapted to the operational reality in the context of risks, and that you offer the proper mitigations technically, but also by and through competency. And that's the way I would react to your comment, but perhaps there are other reactions. Nicole, you want to try?
Well,
we have lunch afterward.
I'm very tempted to say something, but my ICAO friends may not like me. When we talk about competency-based training and assessment, it's a performance-based regulatory environment. That means that personnel in states, in civil aviation authorities, the inspectors, the people who are going to verify that your systems are effective and that you've done your job by, figuring out your whole system. That means the civil aviation authority people who are going to look at your system need to also have a certain set of competencies themselves. So it's moving away, and I'm jumping into the next session, so I apologize for it. But it's moving away from a ticking the box kind of exercise from the inspection point of view, although there are boxes that you need to tick, to an ability for inspectors to look at the whole system, make sure all the pieces fit together. I'll stop right here for now. I'm in enough trouble as it is.
Thank you, Nicole. But it's true. We have exactly the same challenge with performance-based standards or whatever. What it means is that the operator, the training provider, the authority are competent enough to share the same framework, to share the same objectives, and agree together, and perhaps agree also on how to assess the products of the training process. That's really important. with that, okay, hey, you could have raised before. It was totally silent. Okay, 2 last questions and it's okay then. Otherwise, it's your fault if they don't have lunch.
Okay. I would like to ask regarding the competencies identification. Everybody, for example, they decide that we have a different competencies for different operations, for example, and it should not be common. Now the question is, from an authority point of view, whether do you have a procedure to properly identify the competencies needed for that particular, for example, issue, and what would be the best practice to have it as a procedure within your manual, for example, to identify such competencies by saying, for example, garbage in is garbage out. Improper identification of competencies will lead to ineffective competency-based training. So what would be the best practice for this? Thank you very much.
Ashley?
In the PANS training document, they give a high-level process that you can follow. In fact, Nicole raised it a little bit in her presentation in the first session, where you start by defining, if you like, your training specification. And this is kind of, I guess, classic ISD design. But you first need to define what tasks your operator is going to perform. And once you know what tasks they're going to perform, your next question that you ask yourself, and I am trying to keep this fairly simple, the next question you ask yourself is, given this range of tasks that they need to perform, in this particular context, in this particular operation, and under this particular set of conditions, what competencies would I need to see? And for those organizations that don't have, if you like, specialists for doing things like competency analysis from scratch, that is yet again where the ICAO competency framework is this really useful starting point to saying, well, here is a series of competencies that I can start with to ask this question, given this set of tasks, what do I need to see in terms of competence? So to try to keep the answer short, I'm not sure I've done that, there is already a process in PANS training that can help you with that.
Thank you, Ashley. But yes, it's a challenge, but you also have to put in your process the capacity to review what you just decided by experience. Mr. in the back, yeah, you have the floor.
Thank you very much. Thank you very much. My question is regarding the Predator training program, and the debate is if the program designed for non-pilot students or is strictly for experienced pilots, and at the end, I mean, which will be like the next path? I mean, it's okay training non-pilot students or only experienced pilots?
Thank you.
Thanks for asking that question. I think it's a good question, and you're touching on something that I'd hoped that we got a chance to talk to. I guess you should look at my presentation as history. This is what the past 25 years have been for our company. The next 25 years are going to be something entirely different. A common thing that we hear from all of our customers is they don't want to pay for pilots. Pilots are expensive. And I would counter that, yes, we are, but we're worth it. But their bean counters apparently disagree. So there's a constant push from our customers, is they don't want to spend money on training pilots. They want operators who have a less level of competency, or a less level of training, let me put it that way. And then of course our engineers are busy trying to engineer me out of a job as well. And I know this because I assist them in that process. So so that's something going forward. In the past 25 years, it's been really easy because we've been able to use the aviation model, and this is how we train pilots, whether they're manned pilots or remotely piloted pilots. It's essentially the same thing. Going forward, that's going to be changing, and some of our customers have already done that, where they're no longer using qualified pilots, they're using operators. And our system is our engineers are trying to simplify the system so that those operators can operate the system. But the one piece of that is they still have the same responsibilities. Maybe you don't have the stick and rotor skills for takeoff and landing because there's an automatic landing system, but you're still responsible to operate that aircraft in airspace with other aircraft safely. So that's going to be the challenge in the future, I think, is as the industry migrates away from pilots to operators, how are you going to handle that situation?
Thank you, Ed. Yeah, this will be a real challenge because quality of training and competency is very often synonymous to safety, as simple as that. With that, as a last thought of the morning, I'd like to thank you all for your patience to us. I imagine that you now understand what competency-based training is, and I'd like to thank another time our panelists. I think it was a relatively dynamic session. Thank you very much, and I wish you a very nice lunch. Thank you.
All right, thank you, Farid, and thank you, panelists. Somehow I had suspected that this panel might be a little more lively and with questions, so thank you to all of you as well. So before going off to lunch, I would like to introduce Frank Mattis from Thales, where he's the Director, Strategy and Business Development. And Thales is sponsoring today's lunch, so gets to come and tell us a little about what they do at Thales. Mr. Mattis.
Okay, so I am that guy right before lunch, and yes, we'll go through it quickly, and we'll try and cover the topics of UTM. So in the next couple of days, we'll be transitioning from the RPAS conference to Drone Enable, and heading into that, we want to provide you with some food for thought about what the term UTM means. It's one of these terms that gets thrown around in the industry, and we all know what we're talking about when it comes to UTM, and I've had many conversations over the last several days about it. But are we all speaking a common language? So we'll go through sort of our vision of what we think UTM means and where we see the industry heading, and some of the challenges that we'll be facing as we move through the next several years and trying to figure out what this industry will become. So we know that there's something there. There's been enormous growth over the last several years, looking at drones going from basically toys to being able to repurpose drones to do applications that we have thought of in the past, or ones that we're coming up with constantly new applications for drones and different ways to use them. There's a market there that we have to pay attention to. It's growing enormously. There's more and more drone pilots that are being certified, getting their Part 107 licenses in the United States, as an example. There's more commercial applications that are evolving and becoming more prevalent on a day-to-day basis. So we're seeing this enormous growth, but are we really prepared to deal with it? So I want to share with you sort of our operating environment and how we envision UAS traffic management evolving over time. We'll provide these slides so you don't have to take notes, but feel free to take pictures. So we really see UTM as sort of a system of systems approach. When you look at UTM, there's really different components that make up the overall traffic environment. You have a term that's thrown around, which is oftentimes confused for UTM, which is counter UAS. Counter UAS provides a very specialized function that allows you to see where the non-cooperative players are, maybe some nefarious players, or maybe those that just don't know what to do to operate within a confines of an air traffic system. You have a command and control function. This is the way that you communicate with your drone pilots and with the platform itself. How is command and control built into the overall management aspect of the airspace tool that you'll be using in your airspace systems? There's an integration component with air traffic management, which to Thales, if you're not familiar with Thales, we provide air traffic management solutions to ANSPs that cover about 40% of the world's airspace today. So for us, we're in this business because we have to be, and now we can expand on our expertise to help you try and figure out what the impact of small UAS is, or even those that are going to enter your airspace system on a routine basis, how that will impact your overall system from a safety and security standpoint. Interfacing with air traffic is essential. Do we see a one-for-one air traffic management function for drones, especially in low-level airspace? I think the simple answer is no, and we've talked a little bit about that over the last day or so, and we'll continue to talk about it as the week progresses. We're seeing a lot more autonomous function become more prevalent in the overall environment of UTM. There's also a component for of the military side. Military is a major operator in airspace systems around the world, in particular the United States, where there's low-level training routes that the military operates. Sometimes they publish when they're going to operate there. Most times they don't. We can envision a situation where a drone might inadvertently get sucked into an aircraft engine, and that's a bad situation for all of us on a global scale. That would slow us down immensely. So what are different data elements that need to be shared between civil air traffic, military air traffic, and even at the lower levels, communities, figuring out when and where drone operations may take place? How do you prepare for them? How do you ensure that no unsafe situation arises? So for us, bringing together the systems of systems approach, having a performance-based environment exist and not be regimented on how this technology is moved forward is really important in the grand scheme of moving the industry forward. So some guiding principles on putting out an effective UTM system looks something like this. First and foremost, it needs to be safe and secure, and it has to offer an efficiency that is equal to today's air traffic environment. So as more recreational users, as more commercial users start to enter the environment and use the airspace system for their operations, we need to provide them with a safe, secure environment that's tied in with the air traffic management infrastructure already in place to ensure that the entire system is managed safely and efficiently. There has to be a balance between the UTM system and the UAV operators, and really looking at the different capabilities of drones themselves. So today we sort of bundle everything together. So if it's a small UAS, it's from a half a pound up to 55 pounds or 25 kilos. You know, we really need to start looking at segmenting the market for different applications for these types of drones. So what capabilities do you need to have aboard your aircraft to operate within a certain airspace? You should have to have certain levels of pilot qualifications and drone capabilities to conduct certain operations in low-level airspace. So we are advocating for that to continue to evolve. We have to have coordination and deconfliction between manned and unmanned systems. So again, this is a system of systems approach. To have a UTM provider or a company that says that they monitor UTMs or your drone, they may be able to monitor their particular mission, but are they really taking into account everything else that's happening around them? And how does a local facility get in contact with that drone operator to cease an operation or to delay an operation should an unsafe situation arise? All this needs to come together. We need to leverage autonomy both in UTM and in the vehicle. Building up a safety case is essential to moving this industry forward. Without the proper due diligence and work that needs to take place on some of the basic elements of developing the system, like using ground-based sense and avoid technology, using technology that we all know the performance characteristics of, looking at test tools that have been validated against years of design and use, all these tools can now help us move from today's air traffic environment to one in the future where more autonomy will be in place, both on board the aircraft systems themselves, remotely piloted systems, small UASs, and be able to offer autonomy for those users. Again, we want to get the controller out of the loop of providing one-on-one traffic information to the pilot or operator of the drones and have the system control itself. Machine learning will continue to evolve. Are we there yet today? Probably not. We've got a little bit more work to do. Use airspace systems efficiently and deliver safety and security wherever possible. Those are the key tenets to this industry. There's a lot of new commercial entrants into the overall air traffic environment. This is the safest transportation mode of any for a reason. We have over 100 years of history looking at accidents and incidents and loss of life and
ultimately those things had to happen for our industry to move forward. We want to ensure that there are no unsafe situations moving forward. We want to learn from what we've learned over the past several decades and really apply it to the world of UTM.
And finally, sort of the view that I think we're seeing emerge from multiple players in this industry is that this can't be an inherently governmental function. So we need to find a way to provide a level of service to small UAS operators, to remotely piloted system operators, and give them a mechanism to enter the airspace system, get service that they need to ensure that they're not interfering with manned aircraft out there today, and do it at an affordable price. We do see this emerging as a parallel but integrated system where you will need to pay for services, much like you pay for your cable television today or your cell phone plan. We see this as you're using your drone for commercial purposes, you should expect to pay some level of service fee to be able to enter any national airspace system anywhere in the world. So again, I come back to balancing the commercial interest versus where we're at as an industry. So we really see this as sort of an evolving operational roadmap. We've seen a lot of advances in the industry in the last several years, but I think we have a long ways to go before we're comfortable enough that an environment where autonomy and where small UASs can operate beyond visual line of sight to conduct a number of operations will be an environment in which we're all comfortable and we have some performance-based requirements and standards in place to enable that to take place. There's some basic functionality, foundational services, great term, that are already out there today. Mission approval, notification, airspace management, all things that traditional air traffic management companies can work with the regulators and with service providers to provide today. At Thales, we're one of the low altitude authorization notification capability, the LANCE program in the United States. Core members will be rolling out a LANCE capability next month in support of the FAA's program. There are maps that are being published by the FAA to show different altitude levels that are available in and around airports. There's over 19,000 aerodromes in the United States today. Chances are you'll be flying within 5 miles of those. You'll need to get the authorization from the FAA to fly close into those aerodromes. We'll then start to move towards in-flight support and flight monitoring. Those are things like integrating surveillance functions and being able to transfer some of the functions that are traditionally ground-based into platform-based. So having drones communicate with one another, being able to then move towards more self-separation, understanding their environments, figuring out how to deconflict, and we'll see UTM systems playing an important role in enabling that environment. Then we move into more activities where we certainly need to identify and build up to a safety case environment. And again, getting us more towards performance-based and figuring out the safety risk management functions and studies and elements that need to build up this case to ensure that we're all comfortable with how this industry will continue to evolve is needed. So these are operations over people, operations at night, what we like to refer to as the waiverable conditions that the FAA may have put in place, and other ANSPs and regulators probably have a similar list of these as well. And then finally, very high density UAS management is something we're looking at 2020 and beyond. What's the theoretical limitation to and practical limitation to getting a number of drones in a certain element of airspace? Think of it as sector utilization. Is there an overload in a particular portion of that airspace environment? Can we delay operations? Can we figure out a way to shift traffic and not impact a particular area of airspace? So all these things I think we're moving towards in a very regimented manner. Are we moving as fast as we could as some commercial operations or aspirations would like us to? Probably not, but that's okay. I think we as an industry have a pretty good track record in figuring out how to move forward safely and efficiently, and I think we'll continue to do that. So with that, enjoy your lunch. I worked hard this morning making sandwiches, so I hope you enjoy them. It's good. So we'll be at this booth, at our booth outside. If you have any questions, feel free to come see us. Thank you very much.
All right, 2 last comments. One, the presentations from yesterday can all be downloaded on the RPAS 2017 app. And this afternoon, I will have a replacement Master of Ceremony here facilitating for all of you. So Sarah McLaughlin, a friend and good colleague, or good friend and colleague, she'll be here. The be back time, we will recommence at 1400, 2 o'clock. People on the next panel, if you'd be back a few minutes prior to that, we would be very appreciative. Thank you. Enjoy your lunch.